Good morning, student. Last time I have explained the parametric function. Now we have to find another method to find the derivative, that is called the second order derivative. In this chapter we have studied the different kinds of derivative in different ways. So this is the another way to find the second order derivative. You have an information about the derivative. How can we derivative find out of the function, different kinds of function. You studied very well all about the derivative. Now come the one step forward to find the second order derivative. Just you have given that function y equal to fx. Suppose that you have given a function y equal to fx. So we have to find the second order derivative, means first to derive dy by dx with respect to, what can we write? Differentiate with respect to x both sides. Okay, now you can say dy by dx equal to f dash x. Either you can say ddx of f of x, that is called the f dash x. Okay, that is the first derivative. Now come the second order derivative. You have to differentiate second time. What can we write? ddx of dy by dx. You have to write differentiate both sides with respect to x again. Okay, so differentiate this function with respect to x, and the RHS same as it is here, ddx of f of x, f dash x. So now you can see this will come d square y upon dx square, that will come in the second derivative, f double dash x. So in this way you can find the second order, third order and so on. In this way, same time you have to do continue for the first order, second order, third order, fourth order, fifth and nth order you can find. So how can we represent the derivative, second derivative? In the form of function the fx, first derivative the f dash x, second order derivative you have to find out the f double dash x. Similarly you can find the f triple dash x. Okay, nth order you can find out the f of n dash x. 1, 2, 3, n. Okay, n dash x. That is the nth derivative of a given function. So many kinds of representative, many kinds of symbol we can use for, just like this one, y1, y2, y3 and dot 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 up to yn, nth order derivative. These are also a symbol of derivative of a function. Otherwise you can say y1, y dash, y double dash, y triple dash. This is also a derivative. Similarly f dash x, f of x, f dash x, f triple dash x, just like I have explained now. So these are the derivative and symbol. Similarly in the form of ddx, first, second, third and so on, d nth order, dny upon dx raised to the power n. And these are the symbol of all derivative to find out the given function. So in this chapter we have to study only this one. So these are the ways how can we find. You have to do continue after one by one. You can find the first, second, third and so on. So these are the symbol all about the y1, y2, y3. y1 means first derivative, y2 means second derivative, y3 means third derivative, yn means nth derivative. Similarly in the form of dash you can find y dash, y double dash, y dash. In the function, in the form of function we can find fx, f dash x, f triple dash x and so on. Similarly dy by dx, first derivative, d square by dx square, that is called the second derivative, third derivative and nth derivative. In this way we can find the different kinds of function with respect to x in the order of first, second and third and so on. So now come one by one. I love first question number first. What is given first? Find the second order derivative of the following function, just like the x square plus 3x plus 2. X square plus 3x plus 2, that is the given function. So how can we find the, now suppose that let x square plus 3x plus 2. Okay, right question. X square plus 3x plus 2, we have to find the let y equal to, suppose that is x. Either you can choose fx, we have used y, either you can choose the fx, either you can choose the any other function, any other symbol you can use. So first we have to for the second order, first we have to go through first order, first derivative. So what can we write? Differentiate both sides with respect to x. Now differentiate both sides. So what the derivative of y with respect to x? dy by dx equal to into ddx of whole function plus 3x plus 2, and now can distribute this one, ddx of x square plus dx of 3x plus ddx of 2. You can see x square, what the differentiation of x square with respect to x? 2x. Okay, that is called the dy by dx. That is also a dy by dx. 2x and the plus derivative of 3x plus 3. This is the constant, it will 0. What come? dy by dx means 2x plus 3. Okay. This is the first derivative of the function. Now come to the second one. Again for second order. For second order derivative. So again differentiate both sides with respect to x. So now again differentiate. So ddx of, you can see dy by dx equal to ddx of 2x plus 3. So that will become d square y upon dx square, that is called the second order derivative, and ddx of 2x, distribute the derivative in this function, ddx of 3. So d square y upon dx square, that is equal to, with respect to x, 2 into 1 or plus 0, that is equal to 2. Okay, so this is the second order derivative. So the given function x square plus 3x plus 2, and the second order derivative will be 2. So what the answer will be? 2. Okay, this is the solution of this. In this way we have to find out. Now we can't go for other one, otherwise that will become 0. Okay, if we find the third order derivative, we have to again differentiate both sides with respect to x, but this is the constant, so that will become 0. Okay. Second question is the x cos x. So third question is x into cos x. So let y equal to x dot cos x. So differentiate both sides. Differentiate both sides with respect to x. So differentiation of y, dy by dx equal to into ddx of x dot cos x, x into cos x. So you can see that This is the product rule. We have to apply the product. How can we find the derivative of two functions within product? So you have to use the product rule. By using the product rule, we can find the second or first derivative. Okay, how can we say? First as it is second derivative into ddx of second derivative cos x plus second as it is into first derivative into ddx of x. So what the value of cos x differential minus sin x plus cos x into 1. Okay, so dy by dx equal to cos x minus x sin x. Is that clear? Okay, now come to the second. We have to find out the second order derivative. This is the first derivative. Now we have to find out what can we do. Again differentiate both sides with respect to x for the second order derivative. So for the second, again differentiate both sides with respect to x. So ddx of dy by dx equal to ddx of cos x minus x sin x. Okay, that will come d square y upon dx square, that is equal to distribute this ddx of cos x minus ddx of x sin x. Okay, d square y upon dx square equal to cos x, what was our differentiation, minus sin x minus of, again use the product rule, first or second. First as it is second derivative cos x plus second as it is into first derivative 1. Okay, in this way you can find the minus sin x minus x cos x or minus sin x. So minus you can take common outside x. You get sin 2 sin x, what will come? 2 sin x plus x cos x. Okay, in this way we can find out the second order derivative. Sixth question again, e power x sin 5x. Question number 6 we can do in this way. So let y equal to e की power x sin 5x. You can do same as it is. How can we do? Similarly, same process. Simply differentiate. We are writing directly. You can do the language dy by dx. Similarly, differentiate both sides with respect to x. You can say first into second. First as it is second derivative. First as it is second derivative, what will come? Cos of 5x into 5x or into 5x differentiation. Differentiation of 5x will be 5. Okay, this is the derivative of this. First as it is second derivative plus second as it is first derivative, means e raised to the power x. Okay, again differentiation the second time, you can say it either dy by, what we have to write here, again differentiate both sides with respect to x. So how can we write? So that is a d square y upon dx square u into v. That is a constant. 5 will come outside. First as it is, you can write here, that is the first and that is the second. First and that is second. First as it is, second derivative means cos 5x means minus sine 5x into 5 also, derivative of 5x, or 5 is also given another one, plus second as it is 5 you can take outside, no? First as it is, second derivative plus second as it is, first derivative means e raised to the power x. Okay, now this one also, that is the, you can see first, you can second, choose second, same as it is. First as it is, second derivative cos of 5x into 5x, definition of 5x also, 5 another function, plus second as it is sine 5x into another one e raised to the power x, e raised to the power x as it is. Okay, so in this way we can find the and simplify this all. E raised to the power x minus sine 5x, you can arrange minus 5 e raised to the power x sine 5x plus e raised to the power x cos 5x plus, similarly you can do here e raised to the power x cos 5x plus e raised to the power x sine 5x. Okay, in this way you can do, or you can arrange the in the systematic order, you can find the answer.